it'll ask you for a certain probability, and then it'll ask you for degrees of freedom, and it will calculate for you how far you need to go for this particular t-distribution, the one that has 99 degrees of freedom, in order to give you 5% area, not in this tail or this tail, but split between the two tails. So if you want to know how to get 95% of the probability in the meat of the distribution and 5% in the tails for this particular t-distribution, and you have 100 data points and 99 degrees of freedom, this would be the Excel function to use. It seems a bit strange, but there's a bunch of decent exercises in Chapter 1 in the Klebanoff textbook, and that should help you to get some practice so that you can start to do it a half a dozen times, and then it'll be very straightforward. Let me just give you a few, and then we'll switch over to Excel. And once we do the Excel, you'll be able to work along with it and see how things function. So if I have a t-distribution, and I've got 20 degrees of freedom, and I'm at 1.5, the question is, what is the probability that a variable from a t-distribution is greater than 1.5? And this is for t with 20 degrees of freedom. So just ask Excel, t dist 1.5, 21, and it'll tell you the answer, which is about 7.5%. If you want to do a t-distribution for a negative number, it turns out you can't, and the reason is that Bill Gates hates you, or me, or he's just angry, I'm not sure. The t-distribution function will only allow you to put in a positive number for x. It won't let you do a negative number, but again, this is symmetric, just like the normal distribution. So the area in this tail to the left of negative 1.5 is the same as the area in this tail to the right of positive 1.5. And let me just do one more. If you have a t-distribution like this, and again it looks sort of like a standard normal distribution, the question is, with 100 degrees of freedom, how far over do I need to go to get 95% probability in the center? You could see where this is useful if you're constructing a 95% confidence interval. Then I want to have 2.5% probability in each tail. If I have a t-distribution that has very few degrees of freedom, I'll do it below, maybe only 6 degrees of freedom instead of 100, then what happens is, sorry, I should make it, what happens is you get a lot thicker tails, and that means you have to go further out in both directions to get that 95%. So if you have, for instance, 100 degrees of freedom in the t-distribution, then this value here is actually, it's close to that 1.96, 1.985. So if you have 100 data points, your t-distribution is starting to look an awful lot like a standard normal distribution, where this number will be 1.96. It's always close to 2. If you have only 6 degrees of freedom, then you have to go out much further. It's about 2.45. And again, negative 2.45 on this direction. So the more data you have in your data set when you're constructing statistical tasks and doing the sorts of stuff that we do in your your data analysis cores, you get a distribution which is closer to a normal, so the tails become thinner, so you can be confident of your answer without having to give as broad of a range. If you have just 7 data points, you'll have 6 degrees of freedom, and you end up having to go much further, much wider, to cast your net a little further out to be just as confident of getting the true value inside. So the t-distribution, in theory, is not any more complex than the normal distribution, except you've got this degrees of freedom, because again, there's not one t-distribution, there's a whole large family. And working with it a little bit in Excel, I think, should give you an idea for how to put it to work.